I changes what identity and access management must protect. Permissions no longer stop at users and apps. They extend to prompts, data, tools, APIs, and autonomous agents. The goal is clear: powerful AI, bounded by enterprise security. We've already built the IAM foundation: identities, authentication, federation, and policy-driven authorization. Now the question expands. What happens when AI systems request tools, access datasets, invoke models, or act on their own? Traditional IAM asks, can this user reach this app, API, database, or server? AI IAM has to go further. Can the user influence the prompt? Can the model retrieve sensitive knowledge? Can a tool take action, such as sending money or changing a record? Can an agent chain steps together? Authorization now has to protect both information and actions, while limiting leakage, overreach, unsafe automation, and privilege escalation. An AI request is a chain of accountable actors, not one trusted blob. The user has an identity. So does the app. Agents, tools, model access, data services, and backend service accounts each need their own permissions. When a tool needs user context, pass delegated authorization, not the user's raw credentials. That separation supports least privilege, accurate tracing, and containment when one component is compromised. Prompts need access control just like code and configuration. A system prompt may contain policy rules, routing logic, safety constraints, and sensitive business instructions. Permissions should separate viewing, editing, approving, publishing, executing, and rolling back. The right access depends on role, environment, sensitivity, and business ownership. In production, changes should require review, and every execution or modification should be logged for accountability and investigation. Prompt governance continues across the full lifecycle. During design and testing, limit who can author or edit prompts, and keep development, staging, and production access separate. Before deployment, require review and approval for system prompts and high-risk templates. Once live, maintain version history, audit logs, and rollback options. Monitoring helps catch policy violations, abnormal behavior, or unauthorized changes, so unsafe prompts can be fixed or retired quickly. Dataset-level permissions make data access a governance decision, not just a technical setting. Every dataset should be classified by sensitivity, source, legal constraints, and allowed AI use. This applies to training sets, evaluation data, retrieval corpora, and embeddings, because each can expose restricted knowledge. The aim is simple. Models, agents, and users only touch data they are entitled to use, and restricted data does not quietly flow into training, fine-tuning, or retrieval. In RAG systems, authorization cannot happen only when the user asks a question. Permissions need to travel with content as it is ingested, chunked, embedded, and indexed. At retrieval time, the query should include the user's role, tenant, and document entitlements, so unauthorized chunks are filtered before they reach the model. This prevents semantic discovery, stale access after permission changes, and accidental cross-tenant leakage in the answer. Once an AI can use tools, it is no longer just generating text. It can affect real systems. Treat every function as a permission capability. Who may call it, what action it can perform, which resources it can touch, and in what context. Reading data is very different from sending payments, deleting files, or deploying code. Log the tool selected, inputs, results, and user context, so AI actions remain controlled, reviewable, and safe. Connecting an AI assistant to CRM, email, ticketing, databases, and SaaS tools can turn a helpful interface into a powerful action engine. That power must be constrained. Only approved integrations should be callable, and each action should match the user's role and business purpose. Treat every tool request and response as untrusted. Validate it, filter sensitive data, and block risky commands. Also, review each vendor's logging, retention, and compliance practices before enabling access. Think of an autonomous agent like a capable contractor inside a secured worksite. It needs room to act, but not unlimited freedom. Execution boundaries define its identity, the tools and data it may touch, where it can operate, and the time or budget it can consume. They also define stop points, when approval is required, when logging is mandatory, and when risky actions are blocked. Good boundaries let agents move quickly without becoming uncontrolled operators. Agent actions should be treated as decisions, not automatic executions. First, a policy check asks what the agent is trying to do and how risky it is. Low-risk actions may proceed. Code execution, file access, browser automation, or untrusted tools should run in a sandbox. Financial, legal, production, destructive, or public-facing actions need human approval. Runtime monitoring watches for anomalies, retries, and violations, and every system needs a fast emergency stop. When an AI app acts for a user, service, or agent, it should not carry a universal credential downstream. Instead, exchange the original identity for a scoped token that matches the specific API, action, and context. Read, write, export, model invocation, and tool execution are separate permissions. Tokens should be short-lived and audience-bound, so a leak or misuse cannot spread across systems. Avoid the classic anti-pattern, one broad API key everywhere. The pattern is to centralize the decision, then distribute enforcement everywhere the AI system can act. A policy decision point evaluates who the user is, what they are asking for, how sensitive the resource is, and the runtime context. Enforcement points apply that decision at prompt handling, retrieval, tool use, API access, and agent execution. Audit records then connect intent, model behavior, tool calls, and data access into one traceable chain. The key shift is simple. AI IAM protects more than users and apps. Prompts, data, indexes, tools, APIs, and agents all need scoped identities, fine-grained access, and runtime controls. Autonomous agents require extra guardrails. Next, we'll secure the credentials powering these interactions with secrets management and ephemeral access.